Hello and good morning. My name is Jorge Arevalo and today I'm going to explain on how to solve this physics problems. The first problem we have, it says a 35-kilogram dog is being rescued from a pit. He is being pulled up by a motor-driven cable. The pit is 60 meters deep and the motor pulls the dog at a constant speed of 2.0 miles per second. What power must this motor have to perform this task? Okay, so we got the given information. We got the mass that's 35 kilograms, the distance that's 60 meters, the velocity that's 2.0 miles per second, and the acceleration that's 9.8 miles per second. So to do this, we need the velocity formula. That's velocity equals distance over time. And to do this, we know that distance is 60 meters and the velocity equals 2.0 miles per second. So we pass the velocity and put it here, and we divide it into 60 meters over time. After that, we change the positions and divide time, 60 meters over 2.0 miles per second. That gives us 30 seconds. So first obtain the time the dog will take to get out of the pit. To calculate time, we use the velocity formula. It takes 30 seconds to get the dog out of the pit. Next, we must schedule the force. Vertical y-axis acceleration is always 9.8 miles per second. Remember that distance is 60 meters and acceleration is 9.8 miles per second. So, and here we use the force that equals mass acceleration and the mass that is 35 kilograms, and we multiply it. We multiply the acceleration times the distance. The other part is work equals force times distance. And in here we know that force is equal to 343.35 n, and work, and with the work we multiply it. Work equals 343.35 n times the distance, that's 60 meters. After that, we get the answer. That it would be work equals to 20,601 J. After we finish calculating all this, finally convert the power to horsepower. But first, we need to know the powers. Power equals work over time. And work, remember, equals 20,601. So we divide the stuff and know that time is 30 seconds. Time equals to 30 seconds. And we divide 20,601 into 30, and it would equal to power equals to 686. 0.7 work power. Now, finally, we get the horsepower, and here it would be HP equals power over. Hello, my name is Jorge. This time I'm gonna be doing the other explanation of the other problem. The problem says a bead of 5.00 kilograms is released from point A and slides on the frictionless track shown in figure 1. Determine the bead speed at points B and C. So, in here we have velocity article, and this is equal to 0. We know that there is KE, and it equals to 1/2 mv b squared. As there is no friction according to law of conservation of energy, the total energy of particle during motion remains conserved. Hence, the loss in potential energy will be equal to the gain in kinetic energy, and loss in kinetic energy will be equal to gain in potential energy. So now hence, as the particle comes from A to B is VB, then its kinetic energy will be given by K E equals this, and now we have 1/2 over equals mvb squared minus 0 equals 1/2 mvb squared. Vertical height of the particle at A is HA, and that at B is HB. Hence, loss in height from A to B is HA minus HB. And hence, loss in potential energy from A to B is Okay, continuing, we substitute the values, and we have VB squared equals 2 times 9.8 times 5.00 minus 3.20 equals 35.28, and this gives us VB equals the square root of 35.28, which gives us 5.94 miles per second. Now for velocity at point C. At point A, velocity of the particle is 0. Particle is 0. We have again KE equals 1/2 mvc squared. Hence, as the particle from A to C gain in kinetic energy, this will be 1/2 mvc squared minus 0 equals 1/2 mvc squared. Vertical weight of the particle A is HA and the at C is HC. Hence, loss in height from A to B is HA minus HC. And hence, loss in potential energy from A to C is mg HA minus HC. So according to the law of conservation of energy, we